Okay. Wait for a few minutes. Harsh, can you check it that what is classroom location showing in your portal for this lab? Harsh? Okay. Okay. So I'm at the right place. I'm at 2. Yeah. So we'll wait for a few minutes. Once everyone came, then we'll start. Hello, Harsh, Stark, Love, Cordelia. We'll start in a few minutes, okay? Once everyone joins. Just wait for a few minutes. Yeah, so can anybody tell me? I think in the last lab also I'm not able to there. There are some personal reasons are there. Can anybody tell me what is the last experiment you have done? Lab 2 or lab 1? Lab 2, I think you have finished, or 2 or last is lab 1. Okay, okay. So let me just share the screen and tell you that what you're supposed to do in lab 2 and lab 3. Okay. I think lab 2 we have finished. 3 and 4 remaining, if I'm not wrong. Is it so or okay? That's ठीक है कोई बात नहीं चलिए. So what you need to do in the lab, so let me just explain you whatever the remaining lab we have, because in other lab we have reached it at the lab 4. So let me explain you lab 2 and lab 3, and we will try to pop up both of them. I will give you the time, don't worry, but let me explain you what actually you need to do in both of the lab, and according to that you can do the task. Okay. So I think the screen is visible to everyone. Is it so? Yes or no? Okay, it is visible. Yeah. So what you need to do, like in lab experiment number 2, first of all, what is this lab experiment number 2, which is related to the time division multiplexing, TDM. Okay. So what is the TDM actually? TDM, you can say, like whatever the particular signals are there. Let's say you are having a multiple channels, like it's showing in this diagram. Okay, you are having a several channels are there, and you are allocating a specific time for those all the channels. Like you can say you start with the channel number, you will start with channel number 1, and you give it 1 second of time, just for example. So you give a 1 second of time to speak channel number 1. Then in just the next second, you are giving the same time to the channel number B, then channel number C, then D, E. So you are allocating 1 second to all the channels. So if you can say you are having a 8x1 multiplexer and you are doing a time division multiplexing. So you can say there are a 8 second of time slot you have that you are allocating to all of them. Like in 1 second, A will speak, then in second one, B will speak, and then there is a third, C will speak. Likewise, you are dedicated to the specific time slot. So how time division multiplexing actually work, that you can see from this video. So what is your task in this experiment number 2? You need to see the video and you need to identify what is the block diagram of this time division multiplexing. And the diagram you need to draw over here. क्या करना है आप सब लोग को? You need to see this video. It's a 1 or 2 minute video. You need to see that and you need to draw the diagram of the time division multiplexing diagram, whatever showing over there. You need to draw it over here. In a pre-lab exercise, question number 2. What you need to do in this one? Over here, it is giving some of the example, like there are a selection and multiplexer work you already know. Like depend on the selection line you have chosen, that according to that A will go to output, B will go to output. So likewise over here, there are a frame is showing over here. And it is give some initial output. Like for 0, 0, 0, your output is A. 0, 0, 1, your output is B. So likewise, there are a sequence has been given for the different inputs. What you need to do, you need to fill this box. Okay, how you need to fill this block? You need to look for this number. Now, what is the previous output at that number? You need to fill those numbers A, B, C, D in this remaining block. That's the task number 2. A. What is in the task number B? Similar type of the stuff. There are a sample beat selection line numbers, and according to that, output is presented over here. You need to fill the rest of the blocks. Okay, so over here you need to fill the rest of the box by taking a reference of your previous one. Similarly, over here also. So that's the simple task. Draw the TDM block diagram as was shown in this video. Write down the remaining or fill up the remaining box in this one. In the experiment, in the multi-zone experiment, what you need to do? You need to actually create a such type of the time division multiplexing circuit in your multi-sim. Okay. So this is the circuit already given in this task number 2. So if it is not visible to you right now, I think you can download it. ये download हो सकता है सब लोगों को अपने पोर्टल से चेक करिए प्लीज. I think ये फाइल डाउनलोड हो रही है, सबमिशन आप नहीं कर पा रहे होंगे. Is it yes or no? Okay, yeah. So just download it and complete it first. I will give you a time to submit this also, so don't worry about that. So what you need to do, this is a circuit has been given over here. You need to create this circuit, and what this circuit is all about, this circuit is containing a 2 type of the counter. First, which is a Johnson counter, which is 4017 BD, and second is a simple modulo 10 delay counter or decay counter, you can say. So 2 counter is there, and what is the working of this, both of the counter and the circuit? You can identify like that. From this first counter, Johnson counter, it will generate a staircase signal. Like it is generating a 0, 1, 2, 3, some kind of the incrementing manner, such a staircase generated from this one. And you are taking a reference 3 input from here, 2, 3, and 4 number. So 2 having one voltage value, then 3, then 4. So we can say variable type of the square wave or variable type of the digital signal you can feed it. Then after this variable number is going to given into the second counter, as well as it is multiplexed with the wave. All these values like increment type of the numbers and the sinusoidal wave all are going to combine, multiplex, and you can observe it over here. So as you can see, the signal is going to look like this one, like first staircase signal, then higher, and then lower. Likewise, the multiplex signal is from different channel 1, 2, 3. So from channel 1, you can observe some amplitude, then channel 2, but this variation is going to in terms of sinusoidal wave. So you can observe such type of the sinusoidal wave with the discrete sample or with the discrete type of the square wave. That type of the output I'm expecting over here. So what you need to do, you need to create this circuit. Whatever the circuit you have created, you need to paste it over here, as well as you need to paste their diagram, their waveform diagram, whatever you have observed in this function generator. This 2 diagram you need to place it over here. Then after most important stuff, you must write a conclusion. Without conclusion, I'm not accept your submission. Write a conclusion. Do this post-lab exercise. So over here, if you can identify, like by observing to this particular process over here for the hardware, that process has been given, the TP15, TP10 and all. If you are able to identify the answer of this one, that what should be the output, what can be the output over here, you can write it. Otherwise, you can skip this post-lab exercise because it's a totally hardware based. So if you have comfortable to identify the answer with that one, you can write it. Otherwise, you can skip it. Then you need to tick mark over here that what you have learned in this entire laboratory. Okay, that you need to tick mark, and this experiment is. Any doubt in this one? First, in pre-lab exercise, you need to see the video. You need to fill the boxes by taking a reference from previous. In a regular exercise, you need to create a multisim circuit. You need to create a circuit. You need to paste that circuit over here and the waveform, and you need to complete the post-lab exercise if it is possible. Then tick mark, write the conclusion, and this task. Any doubt in this one? Anybody? Please ask me by opening mic or typing in chat box. Okay. Meanwhile, whenever you create a circuit, you can ask me the doubt. It is not any issue. Like ye nahi ho raha hai, iska kya karna hai? You can ask me. Okay, it's a free, and we all are to do that stuff. Let me just give you the brief on the laboratory exercise number 3. What you need to in this 3, we will see. In this experiment number 3, there are the multisim circuit is going to little bit easier than the previous one. So it can be done quickly. What you need to do, like all of us, we have understood analog to digital conversion. So all of you know that there are a 3 stage you have. First is a sampling, then quantization and encoding. Okay. So over here, there are 2 waveform has been given. So forget about this link. Link is not working right now. There are some issues is there with this Purdue University. So don't just confuse with that. I'll just listen to me what I'm trying to say. What you need to do, you can see this is the quantized waveform over here for that blue sinusoidal wave. So you can consider there are a blue sinusoidal wave. It is getting sampled and the quantized signal has been written in the red color. Now, by looking to that quantized signal, you need to write your encoded beats. You need to write the encoded beats for this entire waveform. आपको ये waveform देखना है और हर एक stage पे कौन से beat encode होके निकलेंगे. You need to write that sequence like 110, 101, Likewise, you need to write the entire beat sequence by looking to this pattern. That is the first exercise. What is the second exercise? This right now, its link is not working, but we have already discussed the pulse coded modulation or time division multiplexing in the previous lecture, or we can say in this previous lab in experiment number 2, I already explained that what is time division multiplexing. So what I'm going to do, I will going to share one of the web link instead of this one. You need to read that stuff, that what is a TDM, what is FDM, that link I'm going to share. You need to find out the conclusion, that what you have understood from that, and you need to write your concluding remarks, diagram, waveform, whatever you want to represent, you need to write it over here, that what you are actually understanding from the time division multiplexing. So that conclusive part you need to write it. That's the pre-lab exercise. 2 question, easy. Write the encoded bit. Right. I'm going to share the link over here, and you need to write the answers from that link. Exercise number 3. Already we have this time division multiplexing, so TDM sequence we have. So there are a long hardware-based experiment setup we have. But for right now, you need to create. This is the time division multiplexing based multisim circuit you need to create. So what you can expect over here, what you can identify from this one, you can identify whatever those time division multiplexing output are there, that actually you can see, or actually you can observe over here by using this both of the device. So this first device, which is a ADC, so it will convert analog to digital signal. यहाँ पे आपको क्या मिलेगा? Analog to digital from this circuit. Then this all the digital bits are again fed to DAC. So this U2 is nothing but your digital to analog conversion. तो आप यहाँ पे एनालॉग सिग्नल इसमें फीड कर रहे हो, उसका डिजिटल यहाँ पे जनरेट होगा, फिर से वो डिजिटल सिग्नल एनालॉग के अंदर आप फीड कर रहे हो, और अगेन दैट सेम सिग्नल इज गोइंग टू रिट्राइव इट बैक. So you need to observe by in a over here in a oscilloscope, what you need to observe, that what is the analog signal you have given and what is the reconstructed signal back. आपने यहाँ पे क्या सिग्नल दिया था और क्या सिग्नल आपको वापस मिल रहा है. And by changing this V2, यहाँ पे आप V2 का पल्स चेंज करोगे, 0.01 सेकंड की जगह पे कुछ और चेंज करो, या मिली सेकंड की जगह पे कुछ और चेंज करो, मल्टीप्लाई बाय 10 करो, डिवाइडेड बाय 10 करो, and see what are the difference between input signal and the digital to analog reconstructed signal. तो आपने क्या सिग्नल दिया था, और जो भी नाइक्विस्ट क्राइटेरिया के हिसाब से आप यहाँ पे उसको सैंपल सिग्नल कर रहे हो, तो रिकंस्ट्रक्ट फिर से क्या हो रहा है. So just see the stuff, like what you are going to. Just a second, guys. Let me just. There are. Okay, so what you need to do over here, like what actually the sinusoidal wave you are giving and what sinusoidal wave is retrieving back. And to achieve the perfect sinusoidal wave after this process, what you need to do with this particular pulse or with this source, that is going to be a main observation thing in this entire circuit. So you need to create this circuit and you need to change the value and identify how it's going to match both input signal and that reconstructed signal. So similarly, you need to paste your circuit as well as whatever the different waveform you are getting for the lower sampling, for higher sampling, for a perfect sinusoidal generation, you need to paste it as a output. Then after, you need to write a conclusion, compulsory, and fill out this post-table exercise, and it is easy to do that. It's not that much of difficult. You can use the internet also to fill up that. Write down that related to this sampling, what are the resolution, what are the encoded bits are there. And at the end, you need to tick mark the stuff, that what you have observed from this, all the experiment, you need to tick mark, and that's it. Is it clear? Any question to anybody? Main part is multisim circuit in both of the case, TDM as well as in this A to D conversion or D to A conversion. Any doubt to anybody, please tell me. So start writing that. I'm going to open this particular stuff in a few minutes. So you start with this, download this stuff. You can convert it into the Word and start filling those stuff. And I will give you the 1 week of time. Okay. Like in next week, maximum in next week, you need to complete this both of the stuff. So this lab we have, you can complete the multi-sim circuit today. So just pre-lab and post-lab exercise that is remaining. So try it with very fast, and I am requesting you to please do it little bit of fast so we can reach with this regular other lab also. So I'm humbly request, please do that. Is it okay with everyone? Any questions right now? Please ask me. Or meanwhile, when you're creating this circuit or any doubt, feel free to ask. Is it okay, everyone? Yes or no? I need a confirmation from all the students, all the 16 participants. Please give me your response. Yes, no, sir, clear, whatever you are feeling. Everyone, I'm saying everyone, it means everyone need to write their opinion. Only 4 or 5 students. Okay. So start doing that. Any doubt, any question, you can open your mic, ask me, and I'm going. And soon, everybody just see that in a canvas also. Soon this worksheet are going to upload it. This active learning video making exercise is also going to be live soon. So keep checking this canvas portal for the other exercise. Keep checking that. More task is going on the way, and soon we are going to open these worksheets. This active learning video making surprise test, we are going to open it soon. So do it and keep checking this canvas regularly. Okay. Start doing that. Ask me if you have any questions. And I'm going to generate some of the poll question in mid of this laboratory. So all of you need to attempt those poll questions. So don't sit ideal, don't sleep. You need to give the answer of those poll question. Okay. So wake up and don't sleep in between this laboratory. Please be wake up. Everybody also say in a chat box which topic they are doing right now. Everybody just write in the chat box which topic they are doing right now. Only Harshit has written what he is doing. What about others? Please write what you are doing right now. Please. Yes, what is the status of everyone? Vishek Kumar, Harsh Tak, Vanditu, Anand, R. Vivek, Bhavya, Gopal, Neville, Love, Harshit, Harsh, Ranjay, Vaibhav, Vasu. In just a few minutes, one poll question is going to come to your screen. Just put that stuff over here. So there is one question that I'm going to put it over here in the, as I can say, one of your answers. And you need to write down the short answer of that particular question. You have 5 minutes of time. And after that, all the response that I'm going to display in this screen, and make sure you are not copied and paste from the others, because directly it will it will give me the result that which sentence is just match. Okay, which sentence is just copied and paste or similar type of the sentence that is observed. It's directly said me that particular stuff. So don't copy and paste. You need to write the answer on your word. And the question is going to be available now. See your screen. All the question is there. Start writing the answer. You have a 4 minute 52 seconds. Quickly. What do you mean by TDM? What do you understand from TDM? Write it on your own word, because you have already seen the stuff. So you must need to write the answer. Still, 4 student has not started giving the answer. Do it quickly. You have 2 minutes and 10 seconds. Where 8 students are in progress, 2 students has finished the stuff. Those 4 students who are not attempting this question, going to ask you why you are not attempting this stuff. Please do that. Okay, so the results that I'm going to show you. So this is the whole results. Everybody see that? This is the results. Somebody has written time division multiplexing. Who has written? Hers people, I also know the full form of time division, but what is inside of that? Love Padali has not submitted anything. What is the problem with you, Love? And with that Vanditu, नंबर 52, आप पार्टिसिपेट नहीं करना चाहते हो कोई क्वेश्चन में लैब में? गोपाल विठलानी ऑल्सो, क्या आप आंसर नहीं दे पा रहे हो? जस्ट यू कैन राइट वॉट एवर यू नो. You already seen the video in pre-lab. A way of transmitting, receiving independent signal over a common signal path. Okay, method of transmitting independent signal over a common path. Answer is going to just few sentences, just change few words. Rest of them it's going to same. R. Vivek and Anand Bhavadi. Okay. Which two or more signal transfer, time division, whatever, independent signal over a common path. Is a time. It's method of transmitting individual signal over a common signal. Okay. Okay. Majority answer is going to be okay, but those who have not given the answer, you must give the answer. Otherwise, I'm considering that you are not able to give the answer, so not present in lecture. So don't do that. Give your answer whenever I require. Okay. Start with your regular. So is that somebody has done the multi-sim circuit, completed or not? Any difficulty in multi-sim circuit? Is working or not working? Okay, doing. Let me know, okay, once it will complete and result you will get. Let me share over here my screen so you can also see the reference for that both of them. Let me just share the circuit with you. So this is the multi-sim circuit over here, and I'll just take a 3 signal over here. So the output will be look like this one. If you see, there are a sinusoidal wave generated and there are a different amplitude of pulse going to generated. So if you change their voltage per division, you can get idea. To take their time for a section. You can see there are a variable length of signal is going to generated over here, variable length. Okay, so you can just see that how this pulse is going to vary. Like sinusoidal wave is there, as well as there are a rectangular pulse is also going to be there. So if you just see their detailed zoom version of that, so you can see there are amplitude of that pulse going to change with respect to the sine wave. So amplitude is vary, sinusoidal pulse width is also vary. So it's a multiplexing of all those beats plus the sinusoidal wave. So that whatever the things that we are expecting, that all the 3 signal get multiplexed, that is happening over here. So such type of the output that we can expect. So these are the waveform actually we are expecting over here. Let me just so if you want, yes, just a second. Yeah, so if such type of the sinusoidal wave came, then it's going to okay. So now if you are going to change the other parameter, like whatever this potentiometer are there. So if you change their value of that potentiometer, so their sinusoidal wave, their sequence is also going to change. So if you just change this, all these 3, and you can see their amplitude of that pulse width is going to change. You just change it to the lower one. You can see sinusoidal wave having a higher while square pulse is having a lower stuff. You change this another, then also, so you can see by changing that potentiometer, their effective amplitude is also going to change, the reference amplitude. And according to that, either overlapping sinusoidal on square or square on sinusoidal type of the thing you can observe. Furthermore, if you change this frequency, you change this frequency to 100. So you can see that depend on that frequency value, the number of cycle is also going to be changing. If I'm changing to lower, Again, there are effect of that lower frequency. You can observe. Yes. What is the status? Hers Stark? Hers Vanditu. Open your mic and tell me what you have finished, how much you have completed. Hers and Vanditu. Quickly.
Yes, sir.
So how much you have completed?
Sir, question 1 complete. Yeah.
और बाकी का सर्किट मल्टीसिम का?
सर अब कर रहा हूँ
यार
मल्टी
इतना 2 घंटा लगता है अभी 3 क्वेश्चन लिखने में, थोड़ा फटाफट करिए. Vanditu, what's your status? Vanditu.
Doing the first one.
Circuit?
Yes, sir.
Okay. Anand, Mayank. Anand and Mayank. Tell me your status, where you have reached. Yes?
Yes, sir. Sir, doing 26.
Mayank, R. Vivek. Okay. Okay, R. Vivek is good. Yes. Bhavya, Gopal, Hers. Yes?
डूइंग सर, वो सर्किट वाला.
सर्किट वाला, ठीक है. गोपाल, आपका क्या स्टेटस है? गोपाल, हर्ष. ओके, मल्टीसिम क्वेश्चंस. ओके. हर्षित, लव पाडलिया, नेविल. Done the circuit. Okay, Neville. Harshit, multisim waveform 1, multisim question. Okay. Ranjay, Vaibhav, Vasu. Okay. ठीक है. Everyone just pay attention on the attendance. Let me just share the screen here. Yeah, so start with number 25. Speak up your number. 25, 26. Open your mic and tell me. 27,
Present, sir.
51,
Present, sir.
52,
Present, sir.
53, 54, 56,
Present, sir.
59,
Sir, 57 present.
57. Okay, you write that your enrollment number in chat box. Right now it is not showing in my screen.
Okay, sir.
59, 64,
Present, sir.
65, 65,
Present, sir.
66,
Present, sir.
153, 154, 155. Option number is 25, 26, 53, 54, 59, 153, 155. So if this number is not in the list that I have spoke, you can write it in a chat box.
Sir, 163 is present.
163 is not showing in my list. I think there is issue related to that fees and all stuff. So please, you write in chat box. Okay. Okay. After that writing, if you have question, any query, you can ask me. Otherwise, I'm done from my side. You can leave or you can stay up to 110. Choice is yours.
Thank you, sir.
Thank you, sir.
Thank you. Yes, Ranjay.
Yes, sir.
Yes. So have you finished the circuit or?
Sir just completed a drawing.
Ask me query. Okay. We have 10 minutes.
Okay, sir.